Good evening, ladies and gentlemen, and welcome to today's program as part of IIIT Hyderabad Silver Jubilee Distinguished Lecture Series. IIIT Hyderabad is presently in its 25th year since founding, and we are honored to be having many distinguished lectures, special programs, and cultural performances as part of the festivities. Firstly, I invite the Director of the Institute, Professor Vijay Narayanan, onto the dais to address the gathering. I also invite the speaker of today's distinguished lecture, Dr. Vijay Saraswat, onto the dais. Thank you.
Good afternoon and welcome to another distinguished lecture. As part of our Silver Jubilee celebration, this time we're honored to have Dr. Vijay Saraswat, who is he's a Hyderabadi. He spent his long career in DRDO, different DRDO entities in Hyderabad mostly, and then he was in also Delhi, heading the DRDO, the SA to RM and the DG R&D and all the positions. And he's been working with several other institutions like C.R. Rao Center next door to us. He's been the chair, instrumental in getting it up and going. And I think we are looking forward to his lecture because of his vast experience in technology, science and technology, DRDO, defense. And the last several years, I think ever since the beginning of Niti Aayog, he has been a full member. So he has the perspective of the national needs in that level. So before we invite him for this, I just wanted to say a few words. We are started in 1998. Now we are celebrating our 25 years. And as I was telling you, sir, this is institute that is, we like to say, it is catalyzed by the state government. They gave us the land and building, but no money even from day one. All salaries and bills had to be paid by ourselves, our own money. So technically, as per the government parlance, we are a private institution, but we have no private foundation or family foundation or company that is owning us or dictating anything to us. Neither do we have government department that is controlling us. So we like to think of ourselves as a true public institution, neither a government institution nor a private institution. So, and we focused ourselves on being a top research institution from beginning, and all the undergraduates here also will tell you that in undergraduate program also we expect them to take part in research as much as they can, and they work with us. We are an honors program that they can work 2 years, the last 2 years of their 4-year program with us on some research project. So this has been and this has been we have very large research output and research impact in the world, and our own research itself, like I was telling you, we are ranked maybe 2, 3, 4, 5 in the country in computer science, and definitely a top rank in AI areas. And in the last 5-6 years, we have been focusing strongly on applied research, taking research to the society. Because we cannot have too much, academic research only done in an institution. How do you connect with actual solutions? So we have several efforts going on around AI. For instance, we have a strong research team on transportation. Our researchers work with buses. With Nagpur Municipal Corporation, 300 of buses in Nagpur Municipal Corporation have been fitted with sensors and ADAS devices, and the data comes here every day. And the goal is, this was inaugurated by Nitin Gadkari ji about 2 years ago now. The goal he gave us is reduce accidents and fatality by 50% in 3 years. So we are already on track for that. Data has been coming in, and we are giving warning to the drivers. We are suggesting what modifications can be done to the road. Not we. So this project is we provide the technology, AI or analysis technology. Intel is providing a lot of technology. But as partners, we have CRRI, Central Road Research Institute of CSIR, because they understand what interventions are required to make it safer. We don't understand that. We can only give data. Similarly, NMDC, that Nagpur Municipal Corporation is a partner, and Mahindra, they are doing the vehicle level expertise. So this is one project. A similar project is started here in Telangana about a year ago. This is concentrates on highways. The long distance buses that ply to Vijayawada, to Bangalore, to Pune, etc. They are also fitted with these things, and the data is starting to come in now. This is one kind of we call the iRaste project, which has been producing real result. Other such effort that we have started is in healthcare, typically public health. We want to be involved with the public health. We work closely with the government of Telangana, who've been very supportive of all these. We also work with NGOs on the ground, like Care Foundation in Bihar and few others, because this problem of public health is probably the most important problem in the country, but also difficult to start addressing because so many players are involved. So we are making small beginning. There is a oral cancer screening project we do with the Grace Cancer Foundation, and we have we get data. We also very interestingly tied up with a dental college in coastal Andhra. They actually run 10 or 12 dental clinics across the state, and they are partnering with us. Our solution is using a mobile phone. You image somebody's mouth with suspected of oral cancer, and the software will say what is the risk level, something you should need to take more attention. So it's a screening project. But tying up with the dental clinic was very good because they actually they have experts there. The patients will come there for something else. If you tell them to come here, you will get screening, they may not come at all. So this kind of several such efforts we have been part of now. We would like to ensure that the academic depth that we have is actually put to use so that startups will come, the solutions will come, and that's been one of our endeavors the last few years. And timely enough, we are also awarded a NMICPS a hub on data-driven technology. So we use that fully to do more such activities. We work with IIPH, the Public Health Foundation's entity here. We work with them in some of these projects, and with many other CCMB or IGAB because of the healthcare and other projects. So that's what we have been doing so far. I think in academic research and the traditional metrics of publications, we have done very well. Now next challenge is to see how to take it, translate it to the society, and that's what our endeavor is on. We have several groups that are working on it, and I don't want to say any more because we are all waiting to listen to Dr. Saraswat. So welcome to Dr. Saraswat and all of you to this event. Thank you very much.
Thank you so much, Professor, for setting the stage today. Now we have a short video of our students expressing their views on emerging technologies and their impact on our country's defense.
Namaskaram. So I believe AI systems can help improve our country's defense system. So it can basically predict the enemy behavior, and it can point out our vulnerabilities. So it can save a lot of time and human resource.
AI can be used to find links between various terrorist networks to prevent future attacks.
My name is Nitin. I think AI can be used for a lot of things in country defense, like AI used in guiding missiles and probably choosing a lot of targets. I think this will probably take the human touch out of war and reduce the wars to a number game than more than a loss of physical life.
One potential application I see for artificial intelligence being applied in the defense of this country is in the recognition of foreign nationals entering our country. Another potential application could be the fraud detection in the economic markets.
AI as well as machine learning have revolutionized many industries, right from transportation to pharmaceuticals. According to Accenture, AI will cause double the economic growth rate of 12 developed countries, including the United States of America, and is set to boost labor productivity to 40% by the year 2035. This gives a clear idea of how much impact AI has on our economy, not just technology but other aspects of the world also.
Hi, I'm Samkit Jain. In my opinion, AI can be used for a lot in the defense. It can be used to predict enemy behavior, like a lot of war conditions like weather and terrain can also like be analyzed using AI.
Namaskar Shawaike. As we know that the use of AI is the direst need of the hour in the military logistics systems, as the machine learnings and geospatial systems can decrease the effort, time and error in the military logistics.
AI can be used to strengthen military equipment, specifically in terms of the detection of landmines as well as surveillance of external military operations.
Science and AI today help us solve critical problems and analyze highly complex data when there is a dire need to do so. And it helps save lives and analyze highly complex problems where humans might not be able to step in and solve them very efficiently.
It is now my honor to introduce the speaker of this distinguished lecture, Dr. Vijay Saraswat. Longer introduction now.
Internet, please.
Okay.
Save me from internet.
We'll sit there.
Yeah. No. So if you want to get my, yeah. So, very good evening. Namaskar to all of you. It's an honor to come and talk to all of you today on the occasion of your Silver Jubilee celebrations. At the outset, I would like to congratulate IIIT Hyderabad for being one of the India's most prestigious public-private partnership kind of an institution, which has made its name, which was elaborated, of course, by Dr. Narayana earlier. But I also know that if I look at IIITs in the country, I think we have to go to nowhere else but to Hyderabad IIIT. So that is the kind of institution I have come. It's a pleasure and my congratulations for completing glorious 25 years. My talk is about science technology for sustainable economic development. Actually, I wanted to talk to you about quantum computing as a subject. That was my first choice. But I got a message from here that I should talk about science technology for some usage. Then I dumped that particular topic and now I have chosen this, which I have been talking quite often with educational institutions, with many scientific laboratories and so on. Many of the things which I am going to talk are already being practiced by you, so don't get perturbed on that. The fact remains today that the science has been of great help to the humanity. Its growth has made tremendous impact on the life of all of us. What we cherish today, what we work today on, are all the things which are due to the science and technology. And new technologies have come up, which has opened various opportunities for all of us today. It's up to our imagination and the human mind to explore and exploit all of them. And new minds have to come together. As your video was showing, how many applications of artificial intelligence can have. Similarly, all the disruptive technologies which are emerging today, how many of them are going to come up scale? That's going to be a major difference. And we all need to look at that. But I don't know whether many of you have thought of it. How does science help you in a day-to-day life? Let the lights be on. I think it was good because I can see the faces. Yeah, keep it on. So, I don't know how many of you have really said that in a day-to-day life we have science to play a major role in the society. Dr. Narayana talked about translation. Translation is only for specific applications. But if you look at science, it has three domains: the scientific domain, the technology domain, and the ecological, economic, and the political domain. All these domains come together for you to arrive at a particular decision, and that decision takes you into action. Now, how much of scientific inputs go into that is a very important part. Many times we say that we are being superstitious, so our decisions are being carried forward by that. We are being traditional, so our decisions are being taken that. But how many times you have said that we have been very scientific in taking a decision? That is the question you have to answer yourself. So, science is the principal driver of a change. Now, science-based economy is important today because our Honorable Prime Minister, when he became Prime Minister in 2014, August, September, when we had the first meeting, he said the scientists of this country have not made major impact as far as the society is concerned. That was his first statement. And he said that you should be working towards making science suitable, useful for the benefit of the economy of the country. Since then, we have been all talking about translational research. We have been talking about commercialization of the scientific output of various institutions. We are talking of more and more innovation, incubation, and things like that, which will actually take the scientific output to the market. Now, this certainly has got implications because any scientific output makes a change. For example, the four changes which I have indicated, all of you know, internet made a great social change. The environmental effects which we are discussing today are due to the improper use of the technology by us, which is resulting into the what we call the climate change. The health and medical change is coming mainly because of the biotechnology which is emerging today. And national security, you also mentioned about artificial intelligence making a great contribution to the defense. So, national security has two elements. One is weapons of mass destruction like the nuclear weapons, or defensive weapons where you can fight a tactical war. So, science has the power to completely transform the civilization, which has happened over the last 3 centuries, and science has made life comfortable for all of us. For others, some it has made life comfortable. For some, it could be the kind of war we have in Russia and Ukraine today, where we have all the scientific gadgets which have been developed are being used to sort out issues. The main factor today which is bugging all of us is to change the trend of scientific research, because the technologies which have been developed over the last 2 centuries have always been making negative impact as far as the planet Earth is concerned. In the planet Earth, when you say the climate change, the destruction of the resources, overconsumption, variety of things that have happened, and the difference between the haves and have not increasing, such of those things when they happen, this era became like the era of sustainability. United Nations has evolved what is called the Sustainable Development Goals. All of you know that those 17 goals are that which cover practically every aspect of the human life, right from your living style, your transportation, your education, your health, everything. So SMT for sustainability becomes a very important task. If you continue to do the research, the development of science the way we have done in the last 3 centuries, and do not change the track in terms of making science suitable for sustainability, then we will not be doing the justice in today's world. Hence, there is a need for sustainable development. Now, why do we need a sustainable development? I mentioned about the negative impact of the science and technology over the last 3 centuries, which is, I call it, human drivers which are responsible for that. For example, use of fossil fuels or variety of things which we have done like overconsumption and things like that. So, over-exploitation of the natural resources is one such thing which is responsible for. Why? Because of that, 1 million species on track of extinction and decline of more than 60% of the world's marine fisheries. This is just a number. You look at the climate change, increase in atmospheric temperature and extreme weather events. I was 3 days back in Himachal Pradesh. I just escaped the fury of the nature there happened. Many people died. Probably I would have also, I was driving, I probably would have come into any landslide. I was lucky that I survived, but how many people died because of that? Now all this is because of the climate change which is taking place. People don't realize they go to hills. But you know the climate change, 1.5 degree rise of temperature on the plains is equivalent to 2.3 degree rise in temperature on the mountains. So that is the kind of impact which has hit on the mountains. We are not worried about it. We are saying anybody, okay, let's go and have a holiday on the Himalayas or Uttarakhand or something. But one has to be careful. Rising sea levels, extinction threat to the small island nations, and scarcity of resources, food production. We are now 140 crores of people. Obviously, our food requirements are going up. But our 23% of the world's agricultural land has been degraded. I don't know how many of you know that the Punjab, which is supposed to be the wheat bowl, and now people also say Andhra Pradesh is the rice bowl, the kind of degradation that has taken place, that the water level in Punjab has gone down by almost 50%. The land fertility has gone down by 60%. Overfeeding of the fertilizers, overfeeding of the pesticides has completely spoiled the health of the soil. So that is the kind of effect that has happened. Nearly 2/3 of the world's population will be living in water scarce, water stressed areas by 2025. And you know, India comes under the water scarce nation. I don't know how many of you know that. India has 4% of the world's fresh water resources. And we have 17% of the world's population to feed. So you have a dichotomy there. How are we going to handle this is a problem. So need for sustainable development is there. And for that there are sustainable touch points like digitization for ecology, biodiversity, alternative mobility concepts. Some of you were talking about it. We need to produce durable products. Alternative nutritional concepts have to come. India has a major problem of infantile mortality rate. We have our nutrition index is very poor. So we have to come with the new concepts on nutrition. Energy is obviously one of the major things to take care of that. I'm going to talk about it later also. Alternative urban concepts have to be evolved. In the case of economy and business, like you were changing about translation, the business also is changing. Industry 4.0 is coming. The new systems of manufacturing are coming. Green manufacturing is happening. Efficiency is one of the derivatives there. Computers use is another thing. Positive user experience. Any industry, anybody has to provide a positive experience. Innovation, capability has to increase. Quality has to be brought in. Sustainability has to be there. Customer loyalty has to come. Same thing is happening to education. You are all students and I am talking to the faculty here. The education is a very important part of the societal change. The education, I am going to again talk about it, the race between education and the technology. Human rights, health and protection and so on. So these are the touch points for sustainability. So what is the new thing that one has to do for sustainable development? What is new in science and technology for sustainability? It is bringing together environmental science and development science through research on nature-society interactions. Concern for enlarging scientific capacity in developing countries and providing scientific support for local action. Many times we say what is happening in Delhi does not reach down south or does not reach down because the problems of northeast we are not able to visualize what is sitting in Delhi. We have to look at the local problem with the local action. That's more important. Science that is integrative, that is where natural and social science should be integrated. Sectors of human activity should be taken care of and scholars and practitioners have to work together. Science that is fundamental. One of the things which is required in the science is the scale. Gone are the days when we were all very happy working with the test tubes and living in that kind of a scientific environment. I think every scientific endeavor that has come out from any place needs to see the scale. If you don't take it to TRL 3, then I think you are not doing the right thing. Conceptually you have identified, you will be happy, but at least a pilot should be demonstrated somewhere. So scale. When the processes are non-linear and complex, and the unity of nature and society has to be there. Science that is regional and place-based, where people and ecosystems are, where a transition can happen, where integration takes place, where complexity is understandable. That is the way the new science has to be done. So there are 6 technology transformations for achieving the sustainable development goals. This is not my idea. This has been identified by United Nations today. Digital revolution, which you are part of that, where artificial intelligence, big data analytics, biotech, nanotech, autonomous systems are to be part of that. The smart cities, where all of you are working in different dimensions of decent housing, mobility, sustainable infrastructure, not an infrastructure which is guzzling the energy, not an infrastructure which is polluting, not an infrastructure which is throwing waste on the streets, and not that, sustainable infrastructure, pollution free, food biosphere which is sustainable intensification, biodiversity, forest, all these things. Human capacity improvement is very important. That's why education, health, aging, taking care of the aging people, labor markets which are actually again competitive, gender inequalities, they have to be reduced. Consumption and production, I mentioned to you about resource use. Circular economy. Circular economy is one where you use the used items as much as possible. We can discuss more on that. Sufficiency and pollution. Decarbonization of energy completely. And the main thing is energy access, energy affordability, and energy efficiency. All that has to be made part of that. To all these 6 technologies, there are subsets which are given in the form of disruptive technologies which are making the difference. These are 25 technologies. Many of them are known to you. Many of you on which you are working also today. On top with artificial intelligence, wearables and augmented humans, intelligent spaces, cloud, digital twins, robots, cobots, 5G, machine learning, all that, computer vision, cyber security. I don't have to go into details because most of you know these. But the fact remains that how these are to be made part of the system of translating it into reality for the societal benefit. That is the idea. This graph says that there are foundation technologies like internet, social, mobile, cloud, big data, and there are accelerators like 3D printing, renewable energy, Internet of Things, cognitive systems, which have got what is called the we call it new disruptive scenarios. The black line indicates the disruptive scenario which will create smart grids, it will create connected cars, it will create smart homes, it will give next generation of education, what we saw in the COVID time, and probably even today you are doing hybrids and all that. Smart cities, next generation automation, connected healthcare, Dr. Narayana was talking about it, sharing economy, and so on. The fact is, the 3 graphs are indicative of technology growth is at one pace, then the disruption takes place at a different pace, but there is a phase in between which is called a new economic paradigm, and that is that violet line. So if you use disruption in the right manner, in the right way, all these things which are shown as the disruptive scenario, they can be actually in the new economic paradigm. That is what the message I want to deliver here. Now, these technologies can be divided into 2 parts, what is called the human-centric technologies and the smart space disruptive technologies. Human-centric are those which have got hyper automation, multi-experience, and democratization, human augmentation, transparency and traceability, and all that supporting emerging technologies are known to you, machine learning, VR, AR, data analytics, and so on. In the smart space, you have empowered as distributed cloud, autonomous things. Dr. Narayana and myself, we were talking about creating an AI cloud for ourselves, and I think you guys can make a major difference on that. Practical blockchain. Today there was a demonstration of a very nice blockchain software developed by Sierra Institute. A wonderful work they have done. And AI security. So these are the 2 major portions of the disruptive technologies. All of us have been talking about nano. Why nano? Because nano actually makes a tremendous difference. When we have nanomaterials, nanosensors, quantum, nanosurfaces, nanomedicine, all this leads to, with the integration of the disruptive technologies, what we talked of AI, energy, Internet of Things together, in different disciplines like biodiversity, infrastructure, waste management, water management, resilient buildings. If you integrate all of them, then it leads to what is called the physical well-being, all of you, improvement of the mental health, improved productivity, and better social justice. All of them actually are integrated through the nanotechnologies. Now, how it is done is left to all of you. Somebody will make a nano fiber, but that nano fiber, if you have to use it in some carbon nanofiber, if you have to make it in making a hydrogen cylinder for storing hydrogen for a type 4 cylinder, it is to your ingenuity how you are going to do that. But technology of nano fiber is available. Nano catalyst is available. How you use it to convert carbon dioxide or dissociation of methane into hydrogen and carbon dioxide, how you do that, that's up to you now. So this is the major difference which the nano is taking place. The size of the reactors have come down because of the nano catalyst. The size of devices have come down. The material requirement has come down. And the way the technology is growing, what used to be 15,000 rupees a gram or something, today it is becoming 15 rupees a gram. That is the scale at which the nanotechnology is coming down in terms of realization. IoT, all of you know, I won't spend much time on that because basically idea why I wanted to talk about it. India has a problem. Not that IoT is not known to you. India has a problem in terms of making indigenous IoT. When I want to make indigenous IoT, I need few things. I need data sensing and collection. Device connection, what we call it, data sensing. First thing is that we don't build good sensors. Even today, if I have to have a blood pressure sensor, I look for something coming from outside. If I need a temperature sensor, I look for something from outside. If I look for a humidity sensor, if I need a gas sensing, if I need anything. So sensing devices is a major work which needs to be done, which involves all kinds of technologies, electromechanical, physical, science, chemical, biological, all of them, and they are needed. Then comes the, after data sensing you are done, connectivity. When you come into connectivity mode, edge has to be made intelligent. If you are able to make your edge intelligent, then you are able to call it smart sensor. With that smart sensor connectivity, then your connectivity has to be 5G, 3G, 2G, the Wi-Fi, Bluetooth, whatever that connect. And finally, the data analytics to take a decision. Now, this data analytics is where all the new technologies today, what we are talking of, come into picture, and how much of it is indigenous is again a problem. This is again a question which our Honorable Prime Minister keeps asking. You people are talking AI. How much of AI you are able to do without the help of inputs coming from the Western world? Answer many people are not able to give, because if the Python has not come, R has not come, then probably we will not be able to do half the things what we are doing today on AI. What we need to do is something basic which emanates from the Indian scientific institutions. The smart technologies can be broken into 9 different areas like smart energy, smart building, smart mobility, smart technology, smart infrastructure, smart governance, smart healthcare, smart citizen, and smart security. And each one of them have got, for example, in energy, you need smart grids, because today you have got renewable energy coming, you have constant load energy coming from thermal, you have pneumatic wind power coming from somewhere. Tomorrow ocean energy also will come. Each one has got different variability. Something is DC, something is AC, something has got only 5 hours life, something have lot fluctuations. If the grid is not smart, if you are not able to take care of that, then you are in trouble. If you want to make ease of doing revenue collection, then smart meters are important. So like that, in each sector, we need to put the technology. If you really want to do the smart seamless connectivity, 4G, 5G, broadband, Wi-Fi, as I was mentioning to you. If you want to do e-healthcare, then you need e-health system, intelligent connected medical devices are needed. So all this forms part of the work which you are doing today, but it needs to be now tailored for specific applications. Even today, there are only 1 or 2 companies in the country who are manufacturing smart meters. That's a problem. We are importing smart meters to put in our intelligent meters to be put in our electricity boards. Even today, if I talk of these biometric sensors, I think most of it is coming from outside. So that is where the main problem which our Honorable Prime Minister has been highlighting. Now, economically, if you look at it, the digital revolution is making a change. multi-trillion dollar innovation platforms are there in the form of blockchain technology, genome sequencing, robotics, energy storage, and AI. Multiple trillions in market capitalization over the next decade. It will be possible if we put all of them together. All of you are working on 5G change. I have also seen nowadays, but 5G on transportation, which will make it more efficient and safer, navigation, autonomous driving, healthcare, remote medical examination, diagnosis will be feasible, disaster relief. We are already seeing the impact of that. The way we were handling the Himalaya problem tragedy or Uttarakhand tragedy, it's because today we are much better equipped as far as our communication is concerned. Distance learning in education, we are already seeing. Richer content, multi-user UHD, teleconferences, home security, consumer electronics, all this is 5G. Human capacity enhancement through digitalization. The fusion of 5G, AI and IoT, transportation and logistics is going to improve significantly. AI, you didn't mention about AI-based driver assistance and traffic monitoring systems. Already Delhi, they have started putting the traffic monitoring using the AI. There's a company which is providing the solutions. Self-driving vehicles in India has not come, but I think already in some countries it is happening. Delivery of systems using the unmanned vehicle. Telangana was the first state where unmanned vehicle was used, UAV was used for transporting medicine or a vaccine to a distance of 40 kilometers. But I think now it is becoming a norm. But I have a problem there. The UAV which are being used today by all of them are a combination of the subsystems imported from Singapore and China. Majority of the companies do not understand the physics and the science behind the UAV design. The design does not belong to any one of us. The design belongs to somebody. You don't hold the even IP there. Is that the way we have to do science? No. If I could be a service provider, then I can choose that. But if I am a provider of UAVs for this business, then I should be able to design UAVs, meet the customer's demand, 5 kg payload, 25 kg payload, 50 kg payload, 1 kilometer altitude, 25 kilometer altitude, all that I should be able to work upon. Propulsion system, I should be able to work upon. But that's not happening. Same thing in the industrial operations, factory automation. All the robots in the country today are produced by Hitachi and these companies which are bringing the technology from Japan and other places. So, remote control of industrial robots, remote inspection and maintenance and workers training. Healthcare, the communication certainly, the first good healthcare system I saw was in the Sanjay Gandhi Medical Center in Lucknow, where about 25 villages were connected at the, by one Professor Mishra there. And it's not a today's story, it is about 10 years back story. Using conventional our electronics equipment, some computer, this and communication, and software which he built on that. But I think today, a lot of things are happening in this area. We have a conference here on quantum technologies, and India is marching towards making quantum technology a reality. Quantum computing, which is important, we have to work in that direction, which will be, of course, applications like code breaking, Shor's algorithm, quantum simulation for chemistry field, materials, drug discovery, and so on, machine learning, and hardware in different, about 9 methods are there by which you can do quantum computing. Some of them are being practiced today, like superconducting circuits. TIFR is working on that. Trap dynes, we are working, silicon quantum dots, and many others. Quantum applications, for example, secure communication, quantum key distribution. In this area, I think India has done reasonably well today. Some of the institutions are able to do quantum key distribution over a distance of even 200 kilometers. So, there's a good improvement here. Quantum internet, it's a way to go. But the hardware is very important in this area. Light in the optical fiber and lighting in the free space. That is the technology we have to look at. Quantum sensing is the sensor part. Gravitometry, geosurveys, magnetometry, material science and MRI. Hardware, of course, atomic clocks and NV systems, centers in diamond. The size of the quantum systems which would be needed for variety of applications, I have tried to highlight here. For example, chemistry applications about 200 qubits, or about optimization problems about 1000 qubits. In the case of machine learning, about 10,000 qubits, material science about 1000 qubits, unknown problems, it could be more than 100,000 plus. And these are the areas in which the quantum applications could be there, right from cyber security to weather forecasting, traffic optimization and so on. Healthcare is one of the major areas in which the country is looking at today. And because we want to take the healthcare to the doorstep, that is the aim of the country. And the healthcare technologies include practically every segment what we just now discussed. Automated delivery will involve drones, self-driving cars, augmented reality, which will have connected eyewears and operating room for the future, genetic technologies, which will have low-cost genetic sequencing and genetic genes editing, Internet of Everything, which will evolve into smart appliances, at-home diagnostics and connected clothing, Internet of Everything with quantum edge and cognitive computing with smart appliances, robots and automation, blockchain, 3D printing, all of them will form part of the healthcare technology ecosystem what we are looking at today. You also mentioned about military. I thought I'll certainly talk about military also here. The way the disruption will take place. AI and advanced robotics will give you enhanced data exploitation, improve the decision support system, manufacturing improvement, and unmanned systems, and complete C4ISR. That means command, control, communication, intelligence, surveillance, reconnaissance, and so on. This is the kind of improvement that will happen with the AI and advanced robotics. Semiconductors and advanced computing will certainly improve the cyber operations and shorten the R&D cycles. Quantum technologies will give you tremendous advantage in terms of cyber security, global communication, decryption capabilities, because you can break so many algorithms, enhanced position, navigation, and timing capabilities that will emerge. Biotechnology will certainly help in precision medicine, biological warfare, enhanced soldier performance. When a soldier has to fight war at 18,000 feet, 18,000 meters, I think it's feet, 18,000 feet Khardungla, if I'm not wrong. And when you are going there, the oxygen levels are so low. So we in DRDO used to train the soldiers by our own methods of yoga and mental meditations and all that, so that you can live in that condition without additional supply of oxygen and carry the load also on your body. So this kind of a thing will improve with biotechnology. Human machine teaming will improve. Hypersonic and directed energy weapons, which require the laser technology, which requires particle physics in a big way, for global strike and defeat of missiles, defense systems, anti-satellite systems, anti-missile systems, anti-US capabilities. All this will be a part of the directed energy weapons when a laser beam can finish. Advanced materials, improved military equipment. This is the kind of battlefield which will emerge with the use of these disruptive technology, which is already happening in many countries. For example, Predator, a remote control reconnaissance and fighter drone. It has already been used in the Iraq war. Second one is the Swords, a miniature combat robot which is equipped with cameras and a machine gun and runs on a caterpillar track. For example, a Gladiator, a combat robot, its modular design will allow it to be fitted with mission-specific payloads in the future. An unmanned fire scout, a helicopter, a laser targeting device will even allow it to land on the deck of a warship. And micro air vehicles, which are just the size of 13 inches, that is about 33 centimeters in diameter, currently being tested in Iraq and other places. Then we have unmanned stealth fighters. Stealth means fighters which cannot be detected by the radars and so on. So they are being done. And Big Dog, a walking robot, will be able to carry all sorts of cargo in future. Similar thing will have to happen in the manufacturing segment. The manufacturing segment has been traditional manufacturing, but the technology is driving it to lean manufacturing, which we have already seen. And then came green manufacturing, where we were making manufacturing processes which are environmentally friendly. And they were only using what is called remanufacture, redesign and recover. But sustainable manufacture is a 6R process, the green line, which is innovative, and it uses what is called reduce, reuse, recycle, recover, redesign and remanufacture. That is a kind of cycle, and this is part of your circular economy also. That is the thing, that is the manufacturing system is that. What is the economic impact of all this is going to happen? I just want to give you some numbers. A mobile internet is going to affect the technology and the economy from anything between a pessimistic number of about $3.7 trillion to $10.8 trillion. Automation takes to 5.2 to 6.7. Internet takes from 2.7 to 6.2. So, you know, like that. You see trillions of dollars, all these 12 technologies which we discussed are going to make impact as far as the economy is concerned. If we work for the convergence of these disruptive technologies, what all we can achieve? This is the exercise we did. It can achieve about 550 to 1000 billion annual economic impact, which is 20 to 30% of India's incremental GDP from 2015 to 2025. It can provide 400 million additional people with access to quality health care. It can have 300 million financially included people. It can provide 14 to 24 million workers more years of education. It can achieve 15 to 60% yield improvement for 22 million farmers due to precision agriculture. It can save 50 to 95 billion from energy technologies and gain 17 to 25 billion from intelligent transportation, roads and ports. You are doing some of the projects which Dr. Narayana was mentioning. Create jobs for 10 million tech-enabled workers in healthcare, education, agriculture, citizen services, and financial services. Many of you, I was today addressing some young students who have joined BTech class. I was asking, why did you take computer science? What is the reason for you to choose computer science? The answer was, sir, we get the highest package. So the point is, you can get highest package. That's the kind of thing that can happen. I will not go into details of that. Technologies for energy are very important. I'll just touch upon that because energy is one of the major segments for as far as sustainability is concerned. We are a country which uses coal maximum. So clean coal technologies are needed which will reduce the impact as far as the climate environment is concerned. Carbon capture and utilization technologies are needed where you capture the carbon from the industrial gases or from the atmosphere, capture it. This is the best for mitigating the carbon emissions from difficult to abate sectors. Use of hydrogen, use of alternate fuels like methanol, ethanol and ammonia for variety of sectors. We think that nuclear energy should not be used, but I think the world is again changing into what is called small modular nuclear reactors. These are factory built nuclear reactors. Mobility, all of you know electrification is taking place, hybrids are coming, fuel cells are coming, alternate fuels are coming, and renewable energy and storage systems like battery, pumped hydro, and different kinds of flow batteries and so on. These are the areas which are coming. But for renewable energy, we have to make a tremendous amount of impact in terms of reaching the target. Our Honorable Prime Minister just committed in the top 26-27 that we have to go 500 gigawatts of renewable energy. All of you must have read in the newspaper. But for doing that, our present trend is that we will reach by 2030 only 400 gigawatts. We have to increase our rate by about 35 to 40 gigawatts per year to reach 500 gigawatts. And our investment also has to go from today's $75 billion to something like $223 billion. That is a kind of increase that is needed. Carbon capture I already mentioned to you. Hydrogen is very important in conjunction with the energy efficiency and renewable deployment. We need the power sector a 10% penetration of hydrogen with supply from coal gasification with carbon capture and utilization, and renewable based electrolysis can help reduce India's 2050 carbon emission requirement. So these are the technologies which have to be built, which requires nanomaterials, nanocatalysts, requires cathode materials, requires electrolysis materials, material technology, manufacturing technologies, electrolyzers, all of them are needed. However, hydrogen production via electrolysis from Indian power grid would yield about 30 kilograms of CO2 emissions per kg of hydrogen production. Majority of electricity in India being produced by fossil fuels. In comparison, if you make blue hydrogen from natural gas and also integrate it with carbon capture and utilization, then you yield only 1.7 grams of CO2 per kg of hydrogen. So blue hydrogen is the enabler for green hydrogen. We can use nuclear energy for hydrogen production both in terms of direct thermal decomposition or electrolysis of water. We should switch over to small modular reactors instead of large size nuclear power plants, because these reactors can be built in the factory. They are modular, they are economic, they are flexible in application, they leave much less space as far as setting up is concerned. Replacement of aging fossil fuel plants can be done. Suppose you have a thermal power plant today in some place, maybe in Andhra Pradesh somewhere, you can, Ramagundam, you can replace that with a nuclear plant and it will need half the space. And you know a nuclear power plant can run without any problems for 80 years. That is the kind of life it gives. It is a potential hybrid energy. It can not only give electricity, but it can give you heat. So electricity and heat, that is the kind of advantage it has. So we are promoting now in a big way SMR as a strategy for induction as part of the integration with the base load. As a base load requirement, you meet with the nuclear, and peak load requirements as it is happening, you can take from the renewables. Then it will be a stable option available. So clean energy you can get through these technologies: solar, wind, hydro, carbon capture utilization, green methanol, green aggregate, embrace emerging cleaner resources like hydrogen pumped storage, SMR, and so on. That is the strategy. Industry 4.0 is what we are looking at today, and that would require hyper-connected intelligent society, professional evolution, O2O system, online, offline systems, which are very much coming today. For this, the 9 technologies which are very critical are to be practiced by you. I don't know whether any projects are being taken by IIIT in the segment of Industry 4.0, but I think here is one area where the translation can take place. You have autonomous robots. You are the people who are already doing analytics, data analytics. You are probably working on blockchain, and so the supply chain algorithms can be built on that. Additive manufacturing is not your area, but I think the software, which is very important for additive manufacturing, is the key here that can be also built. Cloud, of course, is part of the system, and cyber security, because ultimately when you have connected machines, automation, security becomes one of the paradigm concern. So do you need cyber security? Industrial Internet of Things. That means supply chain completely connected with the industrial things, horizontal and vertical integration, and simulation and augmented reality. This is where nowadays people are talking of digital twin. And when we have digital twin, you can completely simulate the manufacturing process in your software room, simulation room, and then only feed the data and machine will take care of it. That is the kind of thing that is needed. But all this requires special skills. Industry 4.0 requires special skills, and that is what is expected from all of you. Ability to use automated systems, knowledge of new age technologies, IoT, AR, VR, machine learning, knowledge of cyber security, and statistical knowledge and ability to analyze data generated from machines. Then, of course, cross-functional expertise like understanding of cross-functional processes like chemical process, biological process, mechanical process, all that have to be cross-functional. Focus on client needs, expertise in working under ambiguous and changing circumstances, and so on. So digital skills and cross-domain expertise are likely to become the game changer as far as 4.0 is concerned. Education is important in this case. You have to align the education to Industry 4.0, and for that, like the Industry 4.0 need flexible production line, the education should be tailor-made learning path. The online quality control means you should do formative assessment of the system. Workers monitor automation. Here teachers should become mentors. Custom products, it should be divergence and pluralism. It cannot be custom education. Like that, you have to align the education with the Industry 4.0 requirement. Mechatronics is important. I will not touch upon that. This is the point I wanted to highlight on this. Education and technology have got a race. The blue line actually gives you past and present technology. The yellow line gives you past and present education. And the dotted lines give you the future for both of them. The technology and education, when they run together, there is no concern, no problem. The moment you find that the technology has taken lead over the education, you get a social pain, and that is what is happening in some cases. And that is the past we suffered like that. As we are going up now, our education is improving, technology is come to certain level, so there is a ceiling of what is called prosperity. But technology is not static, technology continues to grow, and that's why the disruptive technologies which are coming today, the 25 which I mentioned to you, are shown by the sharp rise of the technology curve which is shown here, and that is overtaking our education, which is going to create the social pain. And that social pain will remain if we do only incremental changes in our education. That's why country embarked upon NEP 2020. The main idea was not to go for incremental change in the education. Kasturirangan committee main focus was not to focus only on incremental changes but go for major changes. And those future education which is shown by education and the future technology, if we want prosperity, we have to go on the path of accelerated educational changes and keep the pace of the future technology together. Then only we will reduce the pain, then only we can become a prosperous society. So sustainable development needs few things, few competencies. One is system thinking, anticipatory, normative, critical thinking. Another one is the social domain or the emotional domain, which requires collaboration and self-awareness. And last is the behavioral domain, which needs strategic, integrated problem-solving capability. What institutions and universities like you should do, you should instill 4 C's into students: communication, collaboration, critical thinking, and creativity. Make program and ICT education a compulsory subject. Develop educational content in collaboration with industry. Reform content and the methodology of education via digital. Have top people resources to lead global industry engagement and create new business trends through reform of higher education. Industry 4.0, industry university research are the new paradigms that has to be followed. When our Prime Minister says that we should have 5 trillion economy, then what should be our focus? As a technologist, we should focus on design and make in India. Our biggest problem, my dear friends, all of us should realize, and I cannot have anybody who's with not, India is a weak design nation. Our design capabilities are below par in any sector. Every sector, our design capability is a big question mark. Our industries have been taking technologies from outside. 52nd fertilizer plant which is being set up today also is being taken the designs from Italy. 52nd plant. That is the kind of gap we have in design capability. Industry 4.0 is the future, and we should have agriculture productivity, precision agriculture has to come. Development of internet of everything, digital economy has to be given the major push. Education 4.0 and skill development, upskilling. If we are not going to upskill ourselves for meeting the requirement of AI, AR, VR and all that, I think we will be left behind completely. Creation of export-oriented enterprises, clean and efficient energy systems, efficient transportation and logistics, smart cities, infrastructure, service sector, freedom from fossil fuels, alternate fuels and electric vehicles, cyber security in the digital world. This is another area. While we have very smart hackers in the country, but we don't have people who can do cryptanalysis. If I give you a tape recorded version of communication between two countries which are our adversaries, to break the code what is happening, to identify what was our message, we find very, very difficult. It requires tremendous skills of mathematics, statistics, computer science, algorithm analysis, which we are fairly poor in that, and we need to augment our capability there. Defense and aerospace is another area. So need for national policy if you want to make this change. This is my last slide. Embrace potential of new technologies but adapt to national development needs. Government policy is key for adoption of general purpose technologies. Infrastructure, R&D support and business incubator. Mind my word, R&D support. Change in regulations. Reduce, they should help and reduce, manage uncertainty. They should allow for pilot projects to experiment with regulations. Liability, privacy, cyber security should be taken care of. ownership of data should be taken care of, antitrust measures should be inbuilt, more research on impact of new technologies, exchange lessons learned in promoting and managing new technologies, address cross-border aspects of data and information, international access to technologies such as broadband, and international tax coordination. These are some of the measures which we have to take on policy front if we have to support these disruptive technologies to make the kind of economic impact which I mentioned to you. If we do not have these regulations, if we do not have that kind of education system, and if we do not have the skilling what I am talking of, and if we don't look at our own method of research which is leading to translation and custom and taking to market, I don't think we can achieve that 5 trillion goal. So all this has to be done. If we have to do all that, I think India has got the capability. We have all the ingredients. We can do wonderful work, but we have to work together in collaboration with academia and industry. We can then not only compete, but we can outbeat anybody and become a global leader. Thank you very much.
Check. Thank you for that, Dr. Saraswat. Now I call on Dr. Ramesh Loganathan to please moderate the Q&A.
Thank you, Nanda. Sir, you want to sit and take the questions, sir? Or?
I will leave, okay. Standing is best.
Sir, we'd ask some, we'll get questions from the audience as well.
Yeah.
But we had asked some questions before, so let me read out a few before I take the questions from the room. The first one touches upon the CO2 thing that you also mentioned in your talk. Two questions related. One says that a lot of articles we read about that talk about very interesting technologies, but we never see it actually translating. And the related one was somebody asking, like, recently there was an article, I think Walmart also put out, creating fabric from CO2. When such technologies get talked about, do they really get translated to solutions? What we see in the media, we don't really hear. So the question is, like, does it happen as often as it should be happening?
It is happening. Many of these things happen at a low scale which does not come to your notice. It does not come to what is called real market. When it comes to real market, you will come to know. For example, when you mentioned about CO2 to be converted into a fabric, you know CO2 is used for carbon fiber manufacturing. CO2 is one of the input materials for that. You make graphene, from graphene you make another carbon, and then you do what is called carbonization and you get a carbon fiber there. Complete process is, or you make a polyacryl nitrile from that, which is a chemical process. From that again you make carbon fiber. Once you make carbon fiber, you can do anything. We make carbon fiber today, carbon jacket, bulletproof jackets what we make today. It's like kind of a garment which is used. The hydrogen cylinder which is used with the carbon fiber, all type 4 cylinder for carrying hydrogen. 700 bars pressure it can hold. Rocket motors are made in carbon fiber. So once it has come to a scale, it is visible. But there are many technologies which do not get the scale, but they remain so. For example, today I will give you a technology which has surfaced recently, which says that perovskites will be able to give me an efficiency of 35 to 36%. Now, one particular laboratory has done some very small kind of a work there and published a paper. Now, for this perovskite to become a real solar collector as a cell will take significant amount of time. So that is a kind of a problem.
So translating into tangible solutions takes time.
So from going from TRL3 to TRL6 and going from TRL6 to TRL9 is a journey which goes through many valleys of death.
Absolutely, sir. Sir, just any show of hands for the next question. I'll walk up that side. Anybody has a question? Just raise your hand. Okay, just think about the question. Sir, this is a question very connected to our institute, sir. We have a human sciences research group.
Human science?
Yes, sir.
Oh,
so
it
is unlike most other engineering institutions where humanities means leadership and management. We don't teach leadership or management in our human science. It's all about society and many other facets of social and societal aspect. So the question from one of our students, Radheshyam, is in Tripati we have a confluence degree of human sciences and computer science. How can we get involved with policy making, work with think tanks, and get associated with organizations like Niti Aayog?
I think my talk was partially at least covering this aspect, that we have to have integrative science. When you talk of integrate, what is required in sustainability, when I showed that slide, it very clearly says that human science or social science, whatever word you use it, and the engineering and science, other subjects, they have to work together. I don't know whether, when I was a student in 1960s. I did my engineering in 1970. So even at that time, the curriculum and all was not like this. We had a subject on industrial economics and sociology. These two were taught to us. Of course, most of us never took interest in that. That's a different story. But the fact is, we wanted to integrate the engineering with the society's needs. If you want to do the integration, you need to know what the society needs, what are the pains of society. If you don't understand that, then engineering will be devoid of soul. If it is devoid of soul, then it is not good for society. So that's the most important part. Now, how do you become a part of the policy initiative? See, for anybody to become a policy initiative, you have to translate from a hardcore researcher to what is called socio-economic researcher. With your engineering background, you should then see how the technology can translate and reduce the social pain. If you are able to do that, then you can lay down the policies which will use the technology for reducing that pain. That policy you only can make, because translation of a technology for reducing pain requires regulations, it requires certain implementation strategy, it requires certain economic aspects. So all that you will be able to add, because you know the technology and you also know the social pain what you want to reduce. So you can be a policy designer, but you have to change your focus not from just for technology development, but to start translating into social sphere. If you do that, you will be a policy designer also.
Can they get internships, sir, in Niti Aayog?
You can get an internship. We are getting a lot of people. Lot of engineers are coming and doing internship in Niti Aayog.
Sure, sir. We'll get.
You are welcome. B.Tech, you are B.Tech now, so B.Tech third year or second year. First year boys we don't take generally, but second year, third year, fourth year boys.
And our dual degree program has a fifth year also, sir.
Yeah.
It is a B.Tech and
you can come. You can come.
Sure,
and
sir.
we get economics people, we get mathematics people, we get physics people, we get engineers. So you are welcome.
As part of our AI research group, I mean, PGN pushed for
In fact,
this.
we have a program on AI, and anybody who wants to come, AI for societal development. We have a separate theme in which we are, Niti Aayog is working. So anybody, since you have an active AI group here, you can come and contribute in that.
And in fact, PGN has pushed for like looking at the social aspects of AI. So we have one of our faculty who, that's her area of interest. She looks at the social and behavioral aspects of AI.
We have conducted 2 workshops on what is called responsible AI and explainable AI. 2 workshops we have conducted, and we had invited, I don't know whether we invited anyone from you, but we did in Niti-driven workshops. So there is a significant amount of understanding of AI. We are not writing algorithms, I agree. We are not doing any software there. But utilization of AI, AI's capabilities, general AI which is going to emerge tomorrow, the impact of that on society, all that is being discussed. And what policies government of India should have if the AI is driven into various social spheres. What regulations should be there? How do we maintain the data privacy in that case? All that is being discussed in Niti Aayog. So you could be a very good contributor to that.
We'd love to say a lot of work happening
Please
in
do
sustainable
come.
AI
Please
and
do
ethics
come.
in AI.
I invite all of you.
One of our faculty has a question.
Sir, thank you for the wonderful talk. Just wanted to ask from Niti Aayog, what are the up and coming policies that are on the anvil for helping, or encouraging R&D activities in India? You talked about design being one of the gaps that we have. So what kind of policies should be there in place, or are there any up and coming policies?
See, the one thing that came due to the initiative of Niti Aayog particularly was the NEP 2020, which came in the education sector, which has a huge segment on research and development also. It talks about academic research and things like that. The another thing what we are doing is for the inclusiveness. That is, we have a funda or a understanding or a policy. As we say that, our Prime Minister says that country will grow only if the states grow. States will grow if the districts grow. Districts will grow if the blocks grow. So we have been running programs like aspirational districts. We have identified about 120 aspirational districts in different states. And we have done specific policy measures to improve the efficiency of development in those districts. And then we have done a competition. It's a challenge method. If among the districts, if you are scoring better, then you get 5 crores extra. So this has worked very well. Many districts in Telangana, Andhra Pradesh, in many states have really done exceedingly well, and their infrastructure has improved, their schools have improved, their hospitals have improved, their roads have improved, their doing e-business has improved, their skills have improved in many cases. So now we want to take this exercise to block level. So new program which the government has given us 400 crores for that, we are going to run at the block level. It is just sanctioned about 2 months back or something. So this is a new program which is coming. Second one, in the R&D segment, you know, National Research Foundation, which has been designed initially by me as part of the Niti Aayog. But then of course it went through PSA, then went through DST and went through the complete stakeholder consultation. So it has taken some shape. Notwithstanding what is the shape, good or bad, but there is an institution which is going to look at research in an integrated manner. Basic idea is to increase translation as well as give equal focus to basic research. Because as I mentioned to you, there is nothing original about Indian research. We are repetitive and additive. We want to cut this syndrome. Sometimes we should do something which makes a new Indian material, new Indian algorithm for CFD or FEM or electromagnetic or something. Something with the India can say this is done by Narayanan or somebody from here. We are users, we are very good users. And that's why our service sector is doing very well. Because we are able to, APIs we can make hundreds. Beautiful APIs we can make. We are doing that in fintech, we are doing in service sector, e-commerce, everywhere we are doing. That's why we are earning now. Majority of our export earnings are through that. But in the real sense of making, you were talking about product development. Somebody mentioned, I think you mentioned that you have opened a place where you are doing product development. Now, development cannot be done without design. Now, product definition in this case, I know your definition of product development, developing a software module. My definition of product development, developing a computer. It is a combination of software and hardware. Unfortunately, the meaning of technology, you people have completely distorted. Today, when I talk of technology, they only say technology is software. You know, this is technology has become a word for software growth. Technology, nobody talks about hardware. Nobody talks about basic science technology, what we have to do. Nobody is talking about that. Technology, he is a technology guy, means he is working in the IT industry. No? Am I correct? And you say yes or no. This is a fact. You have distorted the definition of technology. Technology is not just IT, sir. You may be triple IT, but you have to accept it.
Absolutely, sir. I think it's a distorted meaning.
Yeah.
Thankfully, Aftab comes from the hardware world. Professor Rajan, our registrar, comes from the geospatial world.
Sir, you are my friend.
So, and we don't have Professor Deva here. So, Deva comes from the sciences, intersection of sciences and computing.
Absolutely.
So, we are trying to bring that, sir. I think one of the thinking in the institute is like, if you don't get the domains also into the institute.
Sir, you say this is Indian drug which has been discovered. This is an Indian material which has been discovered. This is an Indian, I used to tell Professor Sienna Rao in Prime Minister's Scientific Advisory Committee. I was working in DRDO and I was suffering because we had to make what is called focal plane arrays. And focal plane arrays are the devices for capturing IR waves. And these are made out of compound semiconductors like gallium arsenide, gallium nitride, silicon carbide, all these kind of things. We don't have. We can't, and it is denied. France was not giving it to me. For 20 years, the NAG program got delayed because France refused to give us the IR sensors. 20 years. And our chemists, some of them are well-known chemists in the world, they were not able to give me 1 gram of any such material. Now, this is where the Indian science lacks. Whereas in today, there is a professor of 87 years, who I invited him, who is working on converting carbon dioxide into the aggregate which will be used for road construction. You know what is his own? He doesn't want the hills and mountains to be chopped off. He wants to stop carrying exercise. So he has taken this as 87-year age, he is now working on that technology. Where is an Indian scientist who is looking at such things? Unfortunately, we got so much used to additive and repetitive research that we have lost sight of our own innovation. Innovation is creativity. I'm taking the first step of that. I'm not going beyond that. Creativity. First, creativity should come. Then some things will happen.
Sir, absolutely. We have a question for one of our students.
Good afternoon. So basically, you just talked about. I'm Shantanu. I am a dual degree student of applied and cybersecurity, as you mentioned. So
Something happened. Give me a new mic.
So as you mentioned that India is basically lagging behind in the R&D design technology and all. And basically for the emergent technologies like AI, maybe we can like start at the moment and continue with running parallel with all the other nations. But for the classical fields like stealth technology or jet propulsion technology, so the IP of such techs is not basically sold by the nations, no matter the money. So like drawing parallels with what happened after World War II. So basically USA integrated the German scientists into their research area and basically using the technology which the Germany was working for decades.
They upgraded it.
Yeah, they upgraded it. So drawing parallels to the current Russian-Ukraine war. So there was a report that thousands of Russian scientists have been trying to leave Russia. So can't India do the same thing and basically like India imports most of the defense equipments from Russia. So cannot we basically integrate those Russian scientists into India?
We are a nation who is slave to its own governance system. I want to tell you, it is not today. 1995, when Russia broke up, 95, when Perestroika took place, Mr. Gorbachev made open economy, all that. Russia broke up into, Soviet Union broke up into Russia and various other things. The complete economy of Russia went haywire. As a result, hundreds of scientists were migrating because Russia did not have money to pay. I used to go in those days, a distinguished scientist with 70 years of experience, is 80 years or something, 85 years. He was getting $30 per month as a salary. So when a situation like that came, large number of scientists were ready to come to India. And we made a list in DRDO, Dr. Kalam was there at that time. We said, these scientists, we should pick up, allow them. We gave it to embassy, we gave it to everybody. The government said, yes, we can get them, but they will get salary less than that of the cabinet secretary. And the salary of cabinet secretary in 95 was 26,000 rupees. So we are slave to our own system. What happened in China? What happened in Israel? I used to go to Israel also in the same time. They created a separate settlement for Russian Jews. Hundreds of Russian Jews came and settled down in Israel. And today Israel is doing wonderful because some of them were outstanding theorists. Physics, nuclear energy, materials, great scientists, they came. Even nations like Iran, Iraq took it, Hungary took it, China took it. And the complete nuclear technology people went to United States of America. America took it. India did not take it. So, what you say is right. We can and we should make use of all of them. It's not only the foreign scientists or foreign technologists. It is even the Indian diaspora which is now there. Raj Reddy is there in Carnegie Mellon. Many great people are there who have made name. It's not that they are some very normal guys. They have great names. Some of them are working in the multinational companies at the highest level. Even those people we can't get. Because we say, no, we can't give him 5 lakhs rupees per month. We can't give him. That's why the industry is now being allowed, not allowed, told that they should bring in as many foreigners as possible to work for them. But now the Indian industry system does not have R&D ecosystem. Indian industry does not have the R&D eco, and that's why they don't join the Indian industry. They want to come to government agencies. Government agency does not pay them the salary, so they don't come. This is the answer to your question. We are slave to our own governance.
So hopefully academics can play a role here, sir.
Absolutely. That's why we have started a program called Vaishvik, in which I think many of you participated when Satish Reddy was the scientific advisor. We all worked together on that. So now Department of Science and Technology, I am chairing that committee. We are trying to build equations between Indian diaspora and the experts in our own institutions, work out some common projects on which together they can work. We will allow on fellowship those people to come for 3 months minimum. They can go up to 1 year or more also, provided they have the freedom. And we will pay them significant. We have kept, I don't want to disclose that money right now because it's not finalized. We will give them a significant amount of money for them to participate in this. And we won't expect that their parent institution where they are working will contribute any money. We are not expecting that. We are not expecting that. So I hope if that scheme comes, something will happen. But what you said is right. We missed a lot of opportunities.
We have a question from another student there. Please go ahead.
Yeah, hi sir. Thank you for the inspiring talk. I'm Aditya and I study in the MSIT program here. Sir, my question is, as you mentioned, there's hardly any genuine innovation happening in India right now. And as we all know, right from the ancient ages, India has been the source of all kinds of knowledge, science and innovation. What do you think could have been the major reason for this huge setback? Can we solely blame it on colonization alone?
800 years of slavery, and that slavery leading to destruction of the Indian ecosystem. The Indian ecosystem which existed in 700 AD or 500 AD or even 300 BC, that ecosystem was completely demolished. First by the Mughals and later by the Britishers. And Britishers not only demolished that, they made us poorer. We are a rich country. Our GDP was 35% in those days. They not only made us poor, but they changed our cultural system. They brought in a cultural change in Indian society. And who was responsible for that? One person, Macaulay, who created the Macaulay's education system in the country, which created clerks for serving the Britishers. That killed the innovation. And that's why we are a poor innovator. I hope this clarifies.
Sir, we are a little over time. Can we take
no problem?
Questions,
I have no problem.
Okay. Please, anybody else?
Narana wanted to go.
So there's one question here and we'll also have another.
I want a girl to answer a question.
Next one there.
Otherwise, it will not be justified.
The next one is from the girl. Go ahead, Kishore, go ahead. Next one we'll take.
Okay.
Yeah,
so
go ahead.
Continuing on Sub's question earlier, just want to connect or at least hear your thoughts on, because we hear two extremes. One is that semiconductor manufacturing will happen next year or next month versus may not happen in the next decade in the country. So what is the current situation according to you and how do you read it?
See, this is what happens when you are chasing a technology. We are today chasing a technology which has gone leaps and bounds. We made some good beginnings in 1980s when SCL was set up. Even at that time, it was 350 micron technology, whereas the world was still going on 180 at that time. So, the present situation is, we try to do things in a manner which does not support the arrival of foreign companies to help us with the technology. Our efforts to develop our own technologies in semiconductor have failed miserably. DRDO is one among them. We had a solid state physics laboratory from 1960s. We did not do much. I was his boss, so I am to be blamed. And similarly, we had many educational institutions where solid state physics was being done. IITs were also doing. Many small R&D setups were created in IITs, ISCs and all that. But most of them lacked the kind of technology push development that is needed. Today the situation is, we don't have the skilled manpower, nor we have the material base, nor we have the equipment base, nor we have the logistics base to run a semiconductor industry. Semiconductor industry required a good supply chain, good equipment availability, and also technology. And this technology is not software, by the way. This technology is processes, the libraries, they are needed. Unfortunately, the companies who are practicing today on all this, they are into what is called commercial scale production of devices. Each one produces maybe 1 million devices a month and things like that. That is the kind of numbers that is going on, whether it is Taiwan or IBM or Samsung or whatever that. Even China has gone into that lead now. If you ask them to now come and open a shop here, they are finding it very difficult. And that's why all the effort which the government of India has done in 2021 November, after a lot of my pushing, this new policy which came out, that we will spend something like so many $1 billion and we will give 50% grant upfront. People should come thinking that it will happen. This was my idea, because the previous policy that first you set up and then we'll give you money did not work at all. So I said no, unless we make upfront enough. Now what is happening is, people are ready to come. Now they are saying, where's the market? The problem is, we are not the designer, as I mentioned to you. We are not the people who design products. We are only manufacturers. Foxconn also manufactures. All the electronics industry, they import the devices, they import the cards. TV fellows, they import the completely loaded card. So nobody bothers to import a chip, except the DRDO and space and all that, who design their own computers and own navigation system. Maybe you people also must be doing. That's a very small segment. So when there is no market, they find it not very profitable for investing the balance 50%. Third one is, even the government does not give the assurance that they will pick up all the produce that comes out of that foundry, at least for the government projects. At least if they give that kind of a commitment, for example, if I had to produce all the laptops for giving it to the schools in the villages and all, the free laptops and all that, every government is doing today. These are called government purchases. At least if that kind of an assurance is given that we will give you, it will happen. Second thing is, all those who are manufacturing, these are foreign entities. And they are already tied up for the supply of the chips and the devices with large producers. The lateral entry of your chip, which will replace in a laptop or a tablet or a cell phone or in an electronics device, is a big question mark. That's why the development of the product and the infusion of semiconductors has to be a parallel process. It cannot be one after the other. So first we should start manufacturing our own products. You should manufacture your own designs, your own laptop, choose a particular Intel chip or whatever chip, and then you say, I will also give you a chip after, may not be immediately, but after 2 years, I'll give a chip. If you give him that assurance, I'll design for your chip and the product will come, this will happen. So that is called creating the market. If you create the market, companies will come. Since we don't have a market, we have a problem. I hope It gives you secondly what is happening.
Very hard problem, sir. But hopefully with the Micron announcement, at least some headway will
That's
happen.
only ATMP. See, ATMP is also a business model in which the wafer completely etched out comes from this. You do packaging, you do marking, you do testing. It is also industry. It also requires flip chip bonding, all that is needed. But the crux of the matter is the lithography, the making the transistors, building on both sides, making all that. That part is important because that is where the actual crux lies. How much of the heterogeneous junctions you are able to produce, how much of these some of the new materials like germanium and all you are able to interact. That is where the major science is. That changes the memory capability, that changes the speed, the line resolution changes the resolution, whether it's 7 nanometer or 5 nanometer, all that will happen there. Packaging and all that is also important, I am not denying that, but that can be managed.
We had an interaction with the Micron.
It's a business model. For packaging, it's a business model.
We had an interaction with the Micron CEO recently when he was in Delhi.
Gee.
And he was talking about even in US they're struggling to get the right kind of manpower.
US is spending about $220 billion for setting up 22 foundries. Because they don't want to depend on China anymore. And they are also affected by supply chain because there are only 4 companies in the world who are manufacturing the equipment for semiconductor manufacturing. Netherlands, US, and I think Japan. 4th one, I don't remember the name. And if you want to set up a foundry today, if you place an order for a lithography machine, it will take you 1 year to receive. That's the kind of a line which is going on.
Yes, we'll get from
Dr. Saraswat, my question is, I'm here.
Yeah. Good to hear a lady voice.
So, my question is with regards to the amount of investment that happens for core research. So, for example, when you look at the US or parts of Europe, when they want to move forward in any scientific area, the amount of research the amount of money that is set aside for that is very high volume first, and even the distribution is kept very in big chunks. And the big chunks means that you take higher risk. You take a bet on a few people and say, okay, this group will actually go ahead, this center will go ahead and invest in it. In India, typically what I've seen is that the money is usually distributed thin. So as we move towards these frontier technologies, actually the investments required are higher. And it sort of seems to me that the reason why we don't make enough progress is because that right amount of funding is also not there. Do you agree with that? And is there anything that is happening to change that?
Yeah, I entirely agree. In fact, I have been talking about one of the reasons for India's poor research output is subcritical diffused funding. I use these 2 words, subcritical and diffused. You said thinly spread. It is one and the same. This is one reason. But then somebody gave me a reply to that. He said, no, you are not right. You know what was his reply? I don't endorse it, but I am telling his reply. His reply, India is investing 0.6 to 0.8% of its GDP on maybe 1 lakh scientists. Okay. Whereas China is investing 2.5% of its GDP on 10 million scientists. So our per capita investment on scientists is better than that of China. That was the answer given to me. That is one way of a bureaucrat can feel happy about it. That's why I say I am not happy about it, because I look at individual problem. If I had to do, for example, I'll give you an example of this. Quantum computing was first exercise was done in your institute. I came here, we had meeting. Based on that, we made the DPR. We earned it 8,000 crores for 5 years. You know, ultimately, after so much of haggling, how much you got? 6,000 crores. And that for 10 years. Now, if you want to do quantum computing, if you want to do a superconductivity kind of a system, you need refrigerator, you need all the kind of equipment. That one investment itself will cost crores of rupees. If I have to satisfy one professor, that itself will eat up my 10% of the funds. What will I do? And I have to do it, keep that fund for 10 years. So, I agree with you that India continues to spend subcritical amount on critical technology. And we should do something about it. We have been airing this, but then it's a fight, it's a battle.
We had a question here. Somebody had raised hands. Yes. The last question. I think we've already gone way over time. Yeah, this is the last question.
Good evening, sir. I'm Amrit. I'm an MS student here, and I'm working in areas of vision and biometrics. So my question is, you spoke about Niti Aayog and lot of work going around healthcare, right? And even AI, you are trying to promote AI for healthcare. So we all agree that one of the major issues in this area is mental health and emotional well-being and all that. So I just wanted to ask, like, how is Niti Aayog or how are the policies trying to get a solution for it, or what kind of work is going around promoting research for mental health? Because towards mental health, most of the work has been around therapy or counseling. But research has not seen a lot of promotion in terms of funding or whatever, right? So yeah.
See, in our vision document, which Niti Aayog keeps making, we made one in 2015, and another one is coming out now. In between, also an addendum to that came. That's a different story. One point which has been brought out is not with respect to mental health per se, but a very small segment of understanding the brain. And that's why there was a huge push on brain research. One of the organs of the human body which is least understood is even today the brain. Heart is the most understood system. So we had certainly put a major focus on brain research. And because of that, I think you see IIT Madras under the IT giant, Chris has set up a brain research center in ISC. There's one in IIT Madras. All this is happening. As far as mental health is concerned, this has been taken up by Ayush in a big way. And that is where Prime Minister has pushed yoga and meditation as one of the major focus for mental health improvement. That's why Indian yoga got the Philip. The Ayush is the separate ministry which is doing. For that, there's a policy, very clear policy on that. Investment is there. But in the allopathic domain, the brain, the mental health issue has not been given much attention in the allopathic domain by the Niti Aayog. I agree for that.
So we have a cognitive sciences center that works on kind of behavioral and cognitive aspects, and a lot of work happens around brain here.
In fact, that is the kind of work which ISC, Brain Research Center and the IIT, and now the cognitive sciences are linked with the kind of work which was being done in DRDO earlier in the life sciences area, where INMAS and the DPAS, they were working with Professor Banerjee, I forgot his name now. He was doing a lot of work on that, and there's a group there which was being studied. But that was when I was there. I don't know what is the status today.
Yes, sir. One last question.
Pardon?
So, Namaskar. So I am Alimpan, currently pursuing PhD here in computational natural sciences. However, my work is not exactly in computational, so it incorporates experimental work, especially in fields of material sciences, nanosciences, nanobiotechnology. So, what are certain provisions in Niti Aayog for development of new materials which has some potential application in nanobiotechnology, as well as like sensor technologies or storage materials?
Niti Aayog has brought out a report on materials for future, and it has been circulated to all concerned ministries, which includes nanomaterials, which includes bio nanomaterials, which includes all kinds of materials for 3D printing, materials for structural materials, for sensors, materials for defense. Everything is there. It's a very comprehensive study which was done under my leadership, and we could get, we have given it for inclusion at two places. Number one, as a research segment in various IITs, that please do research in these areas. IITs, NITs, and general, central universities also. Another one, what we have done is, we have given it to industry. Those industries which are today, for example, automobile industry. Automobile industry imports the steel for the body of the automobile, the structure. There is a special steel. We call it cold rolled, grain oriented steel, we call it. So that steel is not manufactured. So what we are saying is, we have got steel production centers. We have institutions like National Metallurgical Research Laboratory. We have got DMRL, Defense Material. And they know how to do this. So why are you not doing it? So then came the point that if we do that, will the industry buy it? Then came the question of scale. The production should be at a scale so that it becomes competitive with the supplies which are coming from outside. That is being produced at huge quantities. The scale will never come. So we said that we will, the policy which Niti Aayog gave was that we will provide you the what is called duties on the import. So once the duty on the import material comes, your product becomes competitive and you take it. This kind of policy initiatives we are putting in materials so that industry takes initiative to get it manufactured in India, and also the research should be done on materials, and that has resulted in a couple of things. For example, Indian ship steel used to be imported all the time. So a major program was initiated in DMRL. Now today all the ship steel is done by our SAIL companies and technology developed by DMRL. So like that, it's a I have a presentation which I deliberately did not put it because it gives a lot of details. In the energy sector, materials are a major problem. You know, we say that we have to make 500 gigawatts of solar energy. Have you ever thought of how much of lithium iron phosphate will be needed for making that 500 gigawatts of solar? Your production rate has to be increased to 195%. How much of cobalt will be needed? How much of nickel will be needed? How much of vanadium will be needed? How much of... These are all materials which are needed today, being imported from various sources. So India, as I mentioned in my talk also, sensor and materials are our biggest problem. So that report highlights what are the gaps in the material technology and where we have to do and put forward. I hope that we get the necessary funding. At least the funding, see, it is not Niti Aayog who has to implement now. It is the research laboratories who have to develop those materials. It is the industry like SAIL and others, Hindustan Copper, Hindustan Aluminium and all that. They have to produce those materials. And materials not only to be produced as a powder or a small sheet, materials in the form that it can be used by the production agency. I need a forging, I need a raw stock, I need a tube, I need a bar stock, I need an extrusion. All that means value added product from that material has to come. I need a sheet of 2 meter width. If you give me 1 meter width, the automobile fellow says, go ahead, I don't want this. Because you will bring 2 weld joints in my system, which is not acceptable. So we have to work on those lines. Materials is a nemesis at the moment.
Sir, if you permit one last question, sir.
Sure.
Sir, my name is Nirmal. I have a quick question. You mentioned the Ministry of Ayush. I want to know what is your position on homeopathy and
my position
and the government funding homeopathy.
I am nobody to give any position on that. But as on today, the Ministry of Ayush is promoting all the Indian traditional systems of medicine, which includes homeopathic, Ayurvedic, Unani and all that, Siddha, all these methods they are being done. One of the major initiatives of the Ayush is to understand these systems of medicines in the perspective of the scientific allopathic knowledge about the body. See, we understand the human body better today. We understand how a cell is made, how the cytoplasm is there, how the cell wall is there, what is the how does a protein get attached to the cell wall, how the penetration, all the mechanisms, the cellular microbiology we understand better. Now, if I want to take a gold bhasm of Ayurveda, now I want to see, can I explain the process of gold bhasm treating that particular disease through the mechanisms of cellular and molecular biology, through the biochemistry, through the processes of biotechnology, what to talk about. That is the work which is being done today, in which a lot of good Ayurveda people are involved, working with Ayush. But this is kind of a research activity, it takes time. So the understanding will still remain, उसने दाढ़ी देख लिया, उसने पता लग गया क्या है, you know, it's kind of a jantar mantar. So people have to understand that it is also a science, but understanding of that science has to be created for it to be understood in the present context, in the present perspective of science.
Sir, one in the list that we asked earlier, we had many students ask this question. What should they do to, as young researchers, to be able to work in and for DRDO?
First thing is, don't look for package. If you are looking for package, don't come to DRDO. It will not give you the package. Number two, you should have an aptitude for research. If you are looking for a 9-to-5 job with an intention, whatever comes on your table, you will treat it, and then don't go to DRDO. Third one is, you should be a team man. You should be ready to work as teams. Fourth one is good foundation knowledge of multiple disciplines. Even if you are a computer scientist, I'll tell you, we had a very serious problem in 1985, 86, 87, when we were doing the missile program. That was the first time India was putting a software, embedded software, in a missile system for navigation, guidance and all. Earlier, we never did that earlier. Earlier it used to be those discrete circuits and all that, which used to do all the functions. We didn't have enough number of software engineers. So, late Dr. Arunachalam, who died yesterday, initiated a program to train large number of software engineers in various universities. And almost in every state, 4 or 5 universities taken. And we recruited from MSc program in computer science was created. MSc computer science first time was created, financed by DRDO at that time. In many universities, state universities, central universities, everywhere. And we recruited after that 2 years course, we recruited 700 software engineers between 85 and 95. And those software engineers were pure people coming with physics background or chemistry background, but got into the computer science. And not many of them were engineering background. Some of them were engineering background. Now when they came to us, if he has to write a navigation software, the algorithms also have to be understood. When he has to say that you have to extrapolate based upon data, and you have to do extended Kalman filter. If he has not done extended Kalman filter any time in his life, how will he write that software? So our software was not just, and in those days 85, it was, C was just coming in, we were still in the Fortran mode. He has just come in. And they have to write. So we had to first teach them the basics of those subjects, then they became a wholesome navigation engineer with the software background. Such was the training provided and the platforms we gave them, that these 700 people got reduced to less than 200 in just 5 years. Because that was the time the IT boom was coming in. All of them, these famous companies, the Siemens, this, that, everybody was looking for such people who had disciplined background with software knowledge. And they picked them up at very high remuneration, and that then stopped.
I remember ASIO, one of the labs, some of my friends had joined. Real-time OS, that was probably the only place in Bangalore that work was happening in the late 80s.
Correct.
I remember that, sir. So thank you so much. Sorry, sir, you're going to say something.
No, nothing.
So thank you so much, sir. I'll just hand it over back to Nanda to close it out.
Thank you very much.
Thank you, Dr. Saraswat, for taking time out to come to our campus and to deliver your insightful lecture. We have a small token of our appreciation. I invite Professor Rajan, our registrar, to please hand it over.
Thank you so much.
I also thank Professor Loganathan for effectively moderating a very active Q&A session. I thank the audience for sending in your questions as well as engaging in today's dynamic discussion. Thank you all for coming once again, and we look forward to seeing you again soon. Have a nice day.
I have my bag. Somebody took my computer bag. This from here only, no?
Yes, sir, yours, sir.
I carry it because I know many places this becomes a problem.
Yes, micro USB is still
So a standard USB for me. Thank you.